Hi there folks, in the last video we went ahead and we created the player object as well as the computer class, and we gave them each a turn so that the player would select a cell on the grid, Battleship grid, and then the computer would immediately select select a grid on the player side, and the player would go back and forth, back and forth, back and forth. And obviously all we did was we printed a little hit or miss to the terminal screen. What we want to do in this video is we want to add the tokens to indicate whether a cell has been selected already, and like a visual representation of the game of all the cells that you've already selected as well as what the computer has already selected. So in order to do that, we're going to create a class. It's going to be called tokens. I'm going to come here under my class easy computer. I'm going to create a new class called tokens, and we're going to start off with our define init. Alright, and we're going to pass this class, this object, we will pass it a couple of arguments. The first one we'll pass is the image, the position, the action, then we'll also pass it an image list, which will be equal to none as default. We'll pass it an explosion list, which will be defaulted to none as well. And we'll give it a sound file, which will be equal to none as well. Okay, so self.image will be equal to the image. Self.rect will be equal to self.image.getRect. Right. Now, of course, we've got our self.pos will be equal to the pos given. Self.action, self.pause, then the next few ones will bring in a self.rect.top.left will be equal to our image list by self.pause, excuse me, sorry about that. Self.rect.top.left will be equal to our self.pause. We'll have self.image list, which will be equal to our image list that we pass to it. Self.explosion list will be equal to the explosion list. Next up, self.action will be equal to action, and then we have self.sound file will be equal to sound file. Right, and we'll just leave that one as is for now. Change that spelling. Alright. Sound file. Self.timer will be equal to Pygame.time.getTicks. Self.image index will be equal to 0. And then our self.explosion index will be equal to 0. And our self.explosion will be equal to false. Right, so what we've just created, what's actually going to happen is we've got a couple of things here. So two of our tokens are just a static image. They are the green token and the red token, which the player will, when you select one of the computer grid cells, it's a straightforward green cell for a miss and a red for a hit on the enemy ships. However, when the computer makes a play on your cell, we have a static image for if the computer misses, a standard token image will be represented on that cell. However, if the computer player makes a hit on your ship, we want to then animate a little explosion, and then directly after the explosion there should be a fire on the ship, which will represent the ship then being on fire at that section. So that's the reason why we have the self.image index and self.explosion index. Alright. We're going to go ahead now and we're going to create the Animate Explosion and Animate Fire methods in our tokens list. Very straightforward. We're basically just going to cycle through a bunch of images on the screen. Right, so the first thing we'll do is we'll go to, under tokens, we'll define Animate Explosion. Pass itself, it's always necessary. The little descriptor is going to be animating the explosion sequence, basically. Right. Then under that we'll have self.explosion index. We'll be setting with that attribute plus equals 1. So we're advancing the index number by 1 each time we cycle through, and we call this method if self.explosion index, right, is less than the length of self.explosion list. So as long as the explosion index is still less than the length of the number of images we have for the explosion, it will then return this explosion image, self.explosion list. It's self.explosion index. Okay. Else, we will just return. We will then, once the explosion has reached the end of its cycle, we then want to switch from the explosion list. We want to switch to the animation, the fire animation. So then we're going to call this self.animate fire method. All right. Going on from that means that just below that we need to create the animate fire method. Animate fire method calls itself. Give it a little descriptor. Will be animate fire sequence. All right. Now with the fire, it's pretty straightforward. We're going to run 3 little checks. First one's going to be if the Pygame.time.get ticks minus the self.timer is equal to, is greater than or equal to 100. So basically we want to slow down the flicker between the fire images, slow it down, otherwise the fire will be just like a flash. So then once the Pygame.time.get ticks is less than time, self.timer. So remember now, when we call the, firstly, when the object is created, the explosion object is created, we then create our self.timer, which is Pygame.time.get ticks. Then we call our animation explosion, and then through it, once the animation explosion is finished, cycling through its images, we then call the animate fire explosion. And then the very first check we do is once the animate fire explosion meets that check, self.timer then be equal to Pygame.time.get ticks, which basically means it will be reset. Self.image index then plus equals 1, and that's our first check. The second check we start to run is if self.image index is less than the length of the self.image list. Again, we're checking how long the list is. Return self.image list, self.image index. Right. Else, we must switch the self.image index back to 0. Self.image index back to 0, and we need to return self.image list self.image index, which we've just reset to 0. So basically cycle through the images from the beginning once again. Alright, so we've basically just created our Animate Fire and Animate Explosion functions. The last thing we need to do for the tokens is we need to define our draw method. And I'll pass in an additional element. It's just to the window. Let's give it a descriptor. Draws the tokens to the screen. Okay. So the first thing that happens in this draw method is we're going to check if there is no self.image list window.lit self.image self.rect, which is straightforward. Else, we then need to call self.image will be equal to self.animate explosion. right? Remember, it returns the image, the latest image in the image index. Self.rect will be equal to self.image.getRect. And we want to give it a center, a top left position. Top left will be equal to self.pos. Right, and then self.rect1 will be equal to self.pos. Right, will be equal to self.pos1 minus 10 pixels. And then window.blit self.image self.rect. Alright, so we've just created the token class. The next thing that's left to happen is, when do we actually call these tokens? And that actually happens during our turn when we make our selections of our main attack. So when the player makes an attack, once the player makes an attack, and if that attack is a hit, we then need to call the red token. So actually, before we do that, I just need to create a tokens list. A list that will contain all of our token elements or objects. So we have, there's our loading game variables, there's our loading game sounds and images, buttons. Underneath the buttons, I'm going to create a list here, an empty list called tokens, which will be equal to an empty list. So it's a large list container or list, straightforward. Now in my player class, and I check for make attack, if we've actually made a hit on a ship, I then want to tokens, I want to create a token. So in my tokens list that we've just created, I then want to create a token, tokens, call that class, and the arguments we need to pass to this is we need to pass the image, which will be an image, we need to pass it a position, we need to pass it an action, we need to pass it an image list, if necessary, we need to pass it an explosion list if necessary, and we need to pass it a sound file if necessary. Alright, now you'll notice that we haven't loaded any images yet for our tokens. So we're going to come down to our, first before we go to our utility functions, we're going to go down to our, where's my images? There's my button images, my buttons. Yeah, well, I created my token list right above my tokens list. I think I'm going to create it there. We're going to create a red token variable, and in that red token variable, we're going to say load image, and what it will be is assets, images, tokens, red token. Okay, so we will pass it a path, assets, images, tokens, then red token.png. Right, and the size we want is obviously our cell size. Cell size, I think it is. Yeah, cell size and cell size. That's what we're going to go for. Now we're going to go here and add in the green token, equal to load image, assets, images, tokens. No, come on, come now. Tokens, green token, .png, and then the cells will be the same as above, cell size plus cell size. While we're here, we're going to go ahead and we're going to add the blue token, which will be equal to load image, assets, images, that folded in assets, small letters, images, tokens, blue token.png. We misspelled that word, blue token.png, and the size once again will be cell size plus cell size. Right, the last thing we're going to add to our list, include into our list, we're going to include the Okay, so we've got two types of animated lists. The first animated list we have is our explosion images, which is a set of images that we need to load in. Our fire token images. Fire token images is a set of fire images 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 that we need to load into our fire token list. The second one that we have is the explosion list or images. Now the explosion is actually a sprite sheet, and we're going to specifically load in that sprite sheet and deal with those images separately. So the first thing we're going to go ahead with is let's load in our fire token list image list. Our fire token image list. Have we loaded in any animation images yet? Did we do animation images? Have we built a? Have we done the radar screen yet? No, I don't think we have. We've not done the radar screen yet. Well, we'll do that shortly. So before we do the radar screen, then we're going to build this little function to load in our individual images, each of our images to our list. So to do that, we're going to create a function, and I'm going to create it underneath my load image function. So define, and we're going to call it load animation images, right? And we're going to pass it some arguments. We're going to give it a path, we're going to give it an any animation number, and the size. All right. Descriptor, load in stipulated number of images to memory. Great. So we're going to create an empty list firstly, and then we're going to go ahead and say for num in range any num. If that num is less than 10, image list dot append. Okay, and in this function we're going to call our load image function. Append load image. Then we're going to use some fancy image. We're going to have our path. Path 0, 0 dot png. Okay, and then the size will be size. All right. Let's just get through this, and then I'll come back and explain to you what it is that we're doing, and then when we call the first function, we will have a chance to see it in action. If the number is less than 100, image list dot append load image if path 0 num dot png size. Okay, we actually don't need 3 brackets there. Let's just put that. There we go. And then lastly, in this method, we're going to elif num is less. I'm just going to say else image list dot append load image path and num dot png, right, and size. And then once all that's been done, we will then return the image list. Okay. So what we're doing is we've created this load animation images. So we're going to input a path into this function, a path of the images. So it'll be assets, images, tokens, fire loop, fire1 underscore, and that's where, and space, and that's where we'll end it. Then this path, this texture, because the number is still on the first and the for loop is still below the 10, it'll add a double zero to it, and then the number, which will be whichever number this is, starting at zero, .png. Great. So that's our load animation images. So my fire token image list is going to load animation images. Our path is going to be assets, images, tokens, fire loop, fire 1 underscore space. Okay, the animation number, there is a total of 13 images, and the size will be cell size, cell size. Alright, the next thing we need to create after our fire token image list, the next list item we need to create is our explosion image list. So here we're going to explosion image list. Alright, so this one gets a little bit more tricky. I didn't actually write a function to deal with this section. Or did I? Did I? Okay. Right, let's do this first thing. Explosion sprite sheet. So you'll remember that, so in my explosion, I don't have I've just got one image, it's a ping, bunch of explosions. As you can see, it's one image, and we want to cycle through all of these. Cycle through all of these images. We want to cycle through each one of these explosion images to the end. It's one sheet, which makes it easier because we can just load in one image. So we're going to want to create a Sprite. So what we're going to do is straightforward. We're going to call load in pygame.image.load, and once we've loaded our image, we're just going to load it straightforward. It's nothing special. We're just loading a Sprite sheet, assets, images, tokens, assets, images, tokens, explosion.png. No, we're too early. There's another explosion directory, then explosion.png. Right, let's convert alpha. If you can, should be fine. Alright, now we've loaded that image into the game memory. What we want to go ahead and do now is extract each one of those particular images out of that Sprite sheet. So I'm going to create a little function to do that. Underneath my load animation images, I'm going to create one called diff load Sprite sheet images. Alright. What we're going to pass that is our Sprite sheet and number of rows and number of columns. Okay. Sprite sheet images, and my arguments, we're going to pass it the Sprite sheet, rows, columns. We're going to pass it the new size that we want, as well as the current size. Alright. First, we're going to say we're going to make image is going to be equal to pygame.surface size 128 by 128. Right. Once we've got that, we're going to image.split our sheet. Image.split our sheet. No, our Sprite sheet. Sprite sheet. Image.split our Sprite sheet. 0 from 0, 0. We're going to say rows multiplied by size 0, poles multiplied by size 0, size 1, and then our size 0 and our size 1. Okay. The image will then be equal to Pygame.transform.scale. Right? Because you know we have an image element size 128 by 128. The image that we're going to be transforming, and it's going to be new size and new size. Once we've done it, we just want to say image.set color key to be 0, 0, 0, 0, 0, which is black. And we want to return the image. Alright. So what we're going to do is we've loaded in that sprite sheet. And we've got the number of rows and the number of columns is, or the position that we want on that sprite sheet. So it'll be position 0, position 0. Alright. New size and the size. So then we're creating a surface called an image. Pygame.surface called an image, 128 pixels by 128 pixels. Then on that surface, we're going to blit our sprite sheet object image at position 0, 0. But the rectangle size will be this rectangle here. So the position on our surface is where we're posting the picture, and then this is the position on the sprite sheet where we're getting our picture from. And then once we've done that, then we're going to take our image, we're going to transform it and scale it down to whatever size it is that we want it to be. Then we're going to set the color key. The setting of the color key basically removes the background that we've just input into the game onto the image, the surface, and I was taking it out, and we're returning that image. Then we're going to come back down here to our tokens, our explosion image token list. The explosion image list is going to be equal to, is currently equal to an image list, I believe it is. Yes, it is. And I want to build just straightforward, build a little for loop here to get all these images loaded up. So we're going to say for row in range 8. There's 8 images, not row, let's say row, col in range 8. We're going to say explosion image list dot append, right? Load sprite sheet images, and the sprite sheet that we're going to load is explosion sprite sheet. Rows is going to be row, cols is going to be col, new size, cell size, and then the current cell is images 128 by 128. Let me just double check that quickly. She's rows, cols, new size and size, rows, cols. Do I have them switched around? Yeah. You see, there I've got to swap around there. I need to change it to column, that needs to be row. Alright, now we've got our explosion image list. I'm just going to run this quickly. YZ area. Unresolved reference image around 280. Oh, of course, we forgot about this. I'm just going to comment this section out quickly so we should be able to run our program. Everything should load, but we shouldn't be able to see any of the tokens. We should just be, the game should still be running. There we go. Size must be 2 numbers. Pygame.transform.scale, image, new size and new size. Size must be 2 numbers. Let's branch. Images. 460. 460. New size. Oh, of course. Make that 0. Make that 1. Should run now. It runs. Everything runs like normal. Cool. Alright, so the images we can assume are being loaded in. We'll find out shortly. But we're not running into any errors. Let's put it that way. Now we want to call these items. Once we want to call the tokens and create them at the same time once they get called. So in our player class, we go here by line 280, my tokens, dot append tokens, my image. If it's a hit on the player on the computer grid, it will be red token. Red token. What we're doing is we're loading our tokens, the red token image for a hit on the computer player screen. The position that we will pass to it will be the logic grid. No, not the logic grid. Grid position. IJ, if I'm correct, IJ. Right. The action that we're going to pass to it, that's simple enough. We're just going to pass hit as an action, just text straightforward. The image list, there is no image list, none. There is no explosion list, none. There is no sound file just yet, none. Okay, I just want to quickly run this token check. Let's just run the game quickly. Let's run. If I randomize deploy, so if I select this position on the ship, I should get a red token on top of it. I won't because we're not drawing it to the screen. The last thing we need to do here is in my update game screen method underneath the buttons below the computer.draw window. Yeah. Right over there, we want to for token in tokens the list. We want to do token.draw. Alright, let's try that now. What should happen now is if I start the game, I deploy, and I select this position on the ship, we have a crash. It's all missing one. Of course, we need to get rid of argument, window. Play, deploy the ships, deploy, and if I hit the submarine, we have a red token on top. That is what we want. Fantastic. Of course, the computer is already making his choices as we're going along. That's fantastic. Right, so we've got our token to draw. We've just shown that the red token images are definitely being loaded into the game. We just need to double check for our miss tokens. So if it's a miss, we then need to tokens.append tokens. Then we need to pass it an image. It's going to be the green token at grid position IJ. Action will pass through it as a miss. Again, there's none. Right. The other option we need to go to now is we need to go to our computer player. We need to do the same thing for him under his make attacks. So you'll remember earlier we already created the if it's a hit, print player, hit player ship, etc. So over here we're going to do the exact same thing. Tokens.append tokens. Alright, if it's a hit, we want to then call the which one is it? Which variable do we create for this specifically? We want to use the explosion token. We haven't created. We can just use the red token as well, the red token. However, okay, then we want to also still be at the. No, we're not using the game logic. No, we play game logic. We need the game grid. So it'll be the player game grid. Play game grid, row X, and then call X. That will be the position. The action will still be hit. But now we're going to load in the fire token image list. We're also going to add in the explosion image list, and then still no sound. Right, and if it's a miss, it's going to be straightforward. Tokens dot append tokens blue token player game grid row X player game grid row X call X. Why is it still going player game grid? So define still. Okay, comma. The action will be miss. None. Alright, so we're gonna give this a test now. However, we're not immediately going to be able to see. We now have to wait. Hopefully, have the computer hit one of our ships. So let's deploy. Let's start. Boom. And right off the bat, the computer hits our ship. The computer makes a random miss. Random miss for the computer. Random miss for the computer. Random miss for the computer. As you can see, the explosion happens first, and then it switches over to the fire animation. It's running quite well. I'm happy. You'll see the two fire images are not in sync, which is also what we wanted. Another random, it's a hit, which is fantastic. Good for the ship, but we are still doing better than he is. And then obviously we have one, or we can just keep selecting while he makes. But as you can see, the animations are working. Happy days. This is good news for us. The tokens class has been created and it is working as intended. It's just deployment, soft deployment, deploy reset. Is it not working again? Randomize. Oh, look at that. If we hit the redeploy button, the animation, everything says on the screen. Okay, we'll sort that out shortly. Right. We've just created the tokens. I think that'll be it for this video. I hope you enjoyed it. I hope you were able to follow along and found it not too difficult. And I will see you guys in the next video. Bye for now.